Okay, please take out your homework. So we say we'll go through this today. There is one thing that I want to point out for this type of question, where you have two triangles drawn this way. Okay, you must recognize this diagram. Look at the screen, Zhe, Aloysius. You must recognize this diagram. When they tell you that there are two similar triangles over here, and they tell you that it is actually triangle A, B, C. Triangle A, B, C. Similar to triangle. Now which triangle is this similar to? Let's call this X and Y. Is it going to be similar to triangle X, Y, C or Y, X, C? Okay, what do you think? ABC similar to triangle XYC or YXC? You know that's the difference, right? The difference, huh? So which one is it? YXC. How do you know? One must flip. When you say flip, do you mean rotate? Rotate. Why rotate? What makes you think rotate will be correct? What it say? I didn't say they are the same. They are similar. But which two are similar? Is it XYC or YXC? This one may confuse some people. So there is actually a way to identify it really easily. Yes. C must be the last, obviously. Yes. Okay. What else? So is it XY or YX? YX. Most of you chose this day. Is there anybody who is not sure? Anybody not sure? I think have lah, but maybe shy to say. So I want to tell you. How do you decide? You look at the corresponding angles. Okay. So this angle, if they tell you that they are parallel lines, this angle will be equal to this angle. All right. Then this angle will be equal to this angle. Okay, so you don't just go A, B, C, so the other one must be left to right, then to C. No, it doesn't work that way. It is like the opposite. Y to X, then to C. Okay? Okay, back to this. So you see this similar diagram over there, and they tell you that AOD. So look at the sequence. A to O, then to D. And then next one, C to O to B. C to O, then to B. Okay, you see that? It is like starting from A and then from C, then they go to O, then they go to their respective points. Okay, so these two triangles, they are similar. What else did they tell us? The ratio, BC to AD. BC to AD is 3:5. So this is what you can do on your diagram. You write out 3 and 5. But when you write 3 and 5, please take note that it doesn't refer to 3 cm, doesn't refer to 3 meters, whatever not. It is representing the number of units. It represents ratio. 3 units, 5 units. Okay? In the same way, I am going to use another color. Okay, this one you don't need to copy down. I'm going to use another color to demonstrate. If this is 3 units, then this will be 5 units. Do you agree? But you must recognize that I'm using different colors to tell you that the same colors, we are talking about the ratio between the same colors. The purple 5 and the red 5, not talking about the same length. Ratio wise, there is a relevance over there. Okay, so again, in the same way, we've got a 5 over here and a 3 over here. Okay, so bring a multicolored pen so that you can draw this by yourself. At the same time, you know that, the blue and the purple look very similar. At the same time, you know what you are comparing. Okay, then you don't confuse yourself that they are the length also. Okay, now, what type of quadrilateral is ABCD? The fact that they tell you these two triangles are similar means that I know these two angles are the same. Likewise, I know that these two angles are the same. If these angles are the same, then our conclusion is that these two lines are parallel. If these two lines are parallel, then it is a trapezium. Okay. Now, they only ask what type of quadrilateral it is. They didn't ask you to explain. But if they ask you to explain, then there's a lot more work that needs to be done. I'll just verbally explain to you why it is a trapezium. So listen carefully. Since these two triangles are similar, then like I mentioned, angle ADO, this angle, equals to angle CBO, this angle over here. Since these two angles are the same, by the converse of alternate angles, parallel lines, AD parallel to BC. Okay, because these two angles are the same. And why are they the same? Because they are similar triangles. So similar triangles, angles are the same, therefore converse of alternate angles, parallel lines, these two lines AD, BC parallel. Because these two lines are parallel, then we have a trapezium. Okay? They didn't ask that, so you can just give one word, trapezium. Now find the ratio of BO to BD. Okay, I'm going to erase this. Let's just focus on our BO and BD. BO over here, 3 units. BD, clearly 8 units. So by writing these numbers down, we get the answer straight away. 3 to 8. 3 to 8. Alright, so next one. Straight lines AC, BD. AC, this is a straight line, and BD is another straight line. If they are straight lines, then well, these two are vertically opposite angles, they are the same. And they also tell us that ABE is similar to CDE. So same diagram that I drew earlier on for you. Just do a quick check. ABE from left to right, then to down. CDE, right, left, and up. Okay? So you see there's this, like what Sean said, it's like a rotation. Then there's a scaling involved. Okay? So yes, they are the same. They are similar. Identify the side that corresponds to DC. Well, DC, you can use the name again. DC will be corresponding to BA. BA. Alright? DC, BA. In the diagram. Next, the angle that corresponds to ABE. ABE, well, that's just the name of the triangle. CDE then. ABE, CDE. So where is that angle? ABE and CDE. Find the length of DC. Okay. Now D to C, part B. DC, I want the length, so I find its corresponding side. DC with BA. So DC belongs to the big triangle, BA the small triangle. So I want to use another side of the big triangle, which in this case will be DE, over BE, corresponding side. I'm going to be quite sure that I have all these lengths that are required. So BA 10.2, DE 15, BE 9. So work it out, DC equals to whatever it is. Next one, AEB is X. AEB, X. If this is X, this must also be X. EDC, Y. EDC, this is Y. Then this must also be Y. Find an expression of BAE. BAE, okay, BAE is just, let's see, BAE will be our 180 degrees minus X degrees minus Y degrees. Or you can write it as 180 minus X minus Y degrees. Then state your reason over here, angle sum of triangle. Any questions? Next one, a tent. ABC, cross section of a tent. BD represents the supporting pole. It is perpendicular to the ground. ABD similar to BCD. 40 and 90 cm. Unlike most questions, where they give you 3 sides. See, they give you length of 3 sides. 1, 2, 3. Okay, this one don't have. Then if you look at your notes, they give you 3 sides. Why don't they give you 2 sides over here? How to do? Okay, so find the length of the pole BD. Okay, part A. The unknown is BD, so BD over BD, it belongs to both the small and the big triangle, right? Then you look at the name. Oh, BD is found over here. BD is found over here also. Choose one, just choose one. Let's say I go with the ABD, the small triangle. BD divided by CD. And do we have CD? Yeah, we do. We do have CD. So, I started with the ABD triangle, the small triangle, over the big triangle. So now I'm going to continue the small triangle again. The small triangle, I have another length called AD. AD is the other one. So put down AD. And this time, what is the corresponding side for the bigger triangle? So AD, the other one will be BD. Oh, it's BD again. Right? So normally at this stage, I have been telling you, I'm pretty sure that 3 of the numbers are already found in the diagram. Unfortunately, this is not the case. Let's just do the substitution first. BD over CD, which is 90, equals to AD, which is 40, over, I was expecting a number over here. So I can simply multiply both sides by 90 to get the answer. Unfortunately, this is another BD. Then how? How to solve? Yeah, just multiply lah. It's just one unknown, isn't it? Multiply. And we end up with BD squared equals to 3600. You still can solve it. Okay, even though it is only 2 numbers given to you, but it is still just one unknown only. Therefore, BD equals to 60. And now this is a length of 60. Okay, and it is in cm, right? Yeah, cm. So this is another favorite question where we like to make you obtain a square. Then you end up having to square root. Now next one, angle ABC. ABC, this big angle over here. How to find this? Anybody knows? Anybody managed to get the answer? Which is 90 degrees lah, but do you know why is it 90 degrees? You know? Does it look like 90 degrees? Look like, right, but how? How is it 90 degrees? Any good ideas? Actually, it's similar to this. Okay, give you a clue. If this is x, if it is x, is there another x in the diagram? Omera, is there another x in the diagram? Okay, which other angle is x? DBC. Okay, good. This is also x because they are similar triangles, right? Okay, then got one more angle that I want to find. Let's talk about this angle over here. Let us call it, you can call it y, or if you want to write it in terms of x also can lah. Do you know how to write this in terms of x? Well, this is our one triangle, right? This is 90 degrees. This must be 180 minus 90 minus x, isn't it? Angles are triangle. Because this is our 90, this is our x. So 180 minus 90 minus x. And that gives us 90 minus x. Agree? This one. This is 90 minus x. Oh, this is x. This is 90 minus x. If I add them up, what do I get? 90 lah. So that's the answer. So presentation wise, we can say, let angle DAB be x. So angle DAB, DBC, DBC also equal to x because they are corresponding angles in similar triangles. Okay, next line, we say that angle ABD equals to 180 minus 90 minus x. This is our angle sum of triangle. And that gives us 90 minus x. And then the final line, angle ABC is made out of angle ABD plus angle DBC, which is 90 minus x plus x, which is 90. Any other ways that you all did it? The other option is you let the other one be y lah, y degrees. And you find the other one also y degrees, add them up, they still add up to be 180, so that must be 90. Any other ways that you can suggest? Otherwise, I think these are the few ways. Okay, then the final question. This was from exercise 7.3, finding the scale factor. So scale factor, very simple. The image length divided by the original length. So here they provided so many different lengths for you to choose. Any one of them will work. So this scale factor equals to, let's say, 16 over 12. This is our image. This is the original. Okay, so 16 over 12 we get 4 over 3. Since then, at the same time, you think, just keep reminding yourself, this is bigger than 1, so it got bigger. Look, it got bigger. Makes sense. Whether you use 20 over 15, you still get 4 over 3, 12 over 9, still 4 over 3. Now here we have, we don't know whether this is a rhombus or whatever it is, doesn't matter. This is a reduction, it became smaller. Again, our image on the right. So scale factor, we have 12 over 18, which is 2 over 3. Simple. Scale factor equals to, okay, so for all dimensions, right, for all the figures that we have seen, none of them were circles. They were always triangles, quadrilaterals, or other kind of polygon. This time we have a circle. And we have always been talking about the length of the corresponding side. Does the circle have a side? Circle got sides? No side, right? It only has one circumference. Then this circumference can be calculated using the radius. Okay, so if we want to talk about the ratio of the side for a circle, we should be talking about the circumference. But then you think about it, hey, if I want the ratio of the circumference, it will be, this from this part you don't need to copy, okay? Don't need to copy. If you talk about ratio of the circumference, it will be 2 pi r over 2 pi original r, which is 20, isn't it? Then we notice that they are the same factors, we can cancel 2 and 2, pi and pi. Eventually, the scale factor is just the ratio of the radius. Okay? And in fact, if they did not provide the radius, if they gave you the diameter, it's still going to be the same thing. 30 over 40 is the same as 15 over 20. Okay? So in this case, we could have simplified everything. The scale factor is simply 15 over 20, giving us 3 over 4. Just like in this triangle, you can use 20 over 15 or 16 over 12 or 12 over 9, you get the same answer. You will have the same over here. Okay? In this part B, I just want to show you instead of 12 and 18, if that is not given to you, okay, so if they didn't give this to you, but they gave you something else, let's say, they tell you that, oh, okay, this is instead 6, and they tell you that this is 9. 6 and 9, it works also. They are corresponding sides, they are corresponding length. Doesn't always have to be the age. It can be any length that is corresponding to each other. They can also tell you that this is they can tell you that this parameter 72 cm. Then they tell you this parameter is 48 cm. Still get the same answer. Still works. Okay, now this scale factor, as long as it's the corresponding side, it will work. I will choose 10 over 8 to give us 5 over 4. Okay, any one of them will work, including if they ever give you this distance. Yeah, it works also. If they give you, for example, this distance versus this distance, also will work. If they give you only part of, let's say this plus this, versus this plus this, yeah, it still works. Okay? So some other diagrams that I can show you, maybe it is a crescent. These two crescents are similar. Then the distance over here, same ratio. If you talk about the wider side versus the wider side, same ratio. The curve versus the curve, also the same ratio. Okay? Okay, then that's all for part 2 of the notes. Did you bring part 3? Okay, please take out part 3. Part 3 of your notes on map scale. Okay, now first, conversion of units, do yourself. Okay, no need me to go through. We'll talk about using a map scale. So, exercise number 1. I'll show you different presentations that are allowed. Okay, ready? Must pay close attention. A map scale is given as 3 cm to 1.5 km. 3 cm to 1.5 km. If you are using ratio, it looks like this. Map to actual. You write down 3 cm to 1.5 km. Okay? So remember we said ratio doesn't have units. By right, it shouldn't have units. Then we are talking about, when we say no units, they are actually the same units. 1 is to 2. So it could be 1 apple to 2 apples. 1 cm to 2 cm. 1 liter to 2 liters. If I am deliberately writing out the units, it is because the units are different. So 3 cm to 1.5 kilometers. Then they tell us that the length of the road on the map, 7 cm. Okay, so 7 cm, find the actual length of the road. So how do I go from 3 cm to 7 cm? What should I multiply by? If you can find out this value, we think, then you multiply by the same value over here, you get the actual length on you get the actual length. So in order to go from 3 to 7, we multiply by 7, you divide by 3. Okay, it's like the opposite. So you multiply by 7 over 3. Likewise, multiply by 7 over 3. Okay, so 1.5 times 7 over 3, you get 3.5 km. So our actual length, equals 3.5 km. So this is one presentation that you can use. Okay, the other presentation that I want to introduce you is, I'm going to erase this. Anyway, it's recorded, I hope. The other presentation, 3 cm on map represents 1.5 km. Okay, don't need to say in reality, don't need. 3 cm on map represents 1.5 km. So 7 cm on map will now represent 1.5 kilometers divided by 3 cm. Then you multiply by 7 cm. So I like to use this structure because whenever it's directly proportional, or whether it's about cost, conversion of units, all these are directly proportional. So 1.5 km, just include the units over 3 cm times 7 cm. Okay, then the good thing is you can actually cancel the units like this, leaving us with only one unit, and it is very clear. The final answer, 1.5 divided by 3 times 7, which is 3.5, has the unit of km. Okay, so this is the actual distance. And then now part B, they tell you the actual distance between the school is 6 kilometers. Then find the distance on the map. So now we go the other way around. Both methods will still work. Either you go ratio, okay, but for ratio you end up with a final statement. The distance, the actual distance is so on and so forth, the distance on the map, so on and so forth, whatever. And then the other method is over here. I'll just show you the second method, part B. So we say now, 1.5 km represents 3 cm on map. Now you see it's the other way around already. Because whatever I want to find, in this case I want to find the distance on map, I put the quantities on the right hand side, the distance on the map. So now the actual distance is 6 km. We'll now represent, same structure, divide, multiply. So put in 3 cm over 1.5 km times 6 km. Again, we see that the units can cancel. So 6 divided by 1.5 is 4. 4 times 3, 12 cm. This is the method 2 for presentation. Alright, method 1 still works. Any other types of method, as long as it makes sense, it is clear, also acceptable. That includes some of your primary school ways of doing things. But still same thing, cannot use arrow, cannot draw dash. And die cannot say equal. Okay, so I'll show you the worst kind of mistake that you can make. 1.5 km equal 3 cm. Okay, cannot write this. I know that if you are doing this, then wow, you do the divide the times, you get the same answer. But this is absolutely wrong. You cannot tell me 1.5 km equals to 3 cm. Okay, so the word to use is represent. Okay, next one. Map scale is often written in the form 1 to R. Have you used this in geography yet? No? Not yet. 1 to R. Should have lah. Everybody takes geography over here. The first 1 over here refers to the length on the map. It could be 1 cm, 1 mm, 1 kilometer, doesn't matter. It is a ratio. Whatever unit you put over here, it has the same unit over here. So if we have a case of 1 cm representing 25 kilometers, 1 small cm represents 25 kilometers. Wow, that's very big. Then we write it down this way. 1 cm represents, before that, 1 cm, 25 km. Now we need to convert the 25 km to cm. 25 km will be 25000 meters plus another 20 to be cm. Now that the units are the same, the map scale 1 to R will be 1 to 250 0 0 0 0. 1 2 3 4 5. 1 2 3 4 5. This is the map scale. In the form 1 is to R. If they ever ask you to find the value of R, this is R. But typically the question will be write it in the form 1 to R. So this is what you write as your answer. And obviously, in part B, in the form 1 over R, it will be 1 over 250,000,000. Then it works the same way as your similarity, your scale factor, remember? Your scale factor, when the scale factor is more than 1, then the image is bigger, isn't it? Scale factor more than 1, the image is bigger than the original. When the scale factor is less than 1, the image is smaller than the original. Here we have map scale. Look at this. Is this bigger than or smaller than 1? Smaller than 1, very much smaller than 1. It means that the image is smaller than the original. So there are two things we are talking about over here, the map and actual. Obviously the reality is the original lah. The map is what we shrink it to. So the map scale being less than 1 tells us that the original has been shrunk to a smaller map scale. So this you can do by yourself. Make sure you change them to the same units. This also you can do it. So this find n. slightly different, instead asking you to express in the form 1 to n. Okay, all these you can do, all these can do. Okay, so your homework is until exercise 5. Sorry, exercise 6. We have covered what we need to already for your homework.